Thank you for taking the time to watch this video demonstration today. Over the next 18 to 20 minutes, we're going to spend some time walking you through a Jenkins, Apprenda, NetApp integration demonstrating how we use a CI/CD workflow to support applications being put from a development into a production environment. Before we begin this demonstration, I want to highlight 5 elements that are important to understand before we get into the discussion in detail. We've used GitLab locally on NetApp, a combination of RESTful APIs for ONTAP 9, CloudBees Jenkins Enterprise version, Docker 1.1.2, and Apprenda version 6.5. We'll be comparing the traditional approach using multiple Git clones to create development environments versus the approach used in this plugin, which creates one CI instance that can be cloned quickly and efficiently for use by developers and CI admins. There are 4 components to this CI/CD workflow that we'll be talking about. The source code management component, or SCM, a continuous integration component, or CI, a development component, and a build artifact component. These are all part of the overall CI/CD workflow. So let's start off by talking about how the traditional method is used. For the purposes of this demonstration, I want to talk a little bit about the back-end systems that are used to support both the traditional and the optimized case we're going to be showing you. We've used an 8-core CPU with 64 gigabytes of memory and a 10 gigabyte uplink to the WAN where we'll be downloading Jenkins open source software, or OSS. In the traditional use case, we'll be creating 3 separate developer workspaces using Git clone for each of these developers in succession. You'll see here how we're building the developer workspace for developer 1. This process is then repeated for developers 2 and 3. In this next stage, we're going to demonstrate how the optimized method works using a combination of NetApp, CloudBees Jenkins, and Apprenda to create a single Git clone instance that will be used as the foundation for all developers to build their development environments from. It's important to note here that the key difference between the optimized approach and the traditional approach is that the optimized approach creates this single instance, whereas in the traditional approach, a Git clone needs to be created for each developer workspace. You'll see here how a Jenkins master is created on Docker on Apprenda's PaaS platform. Next, a local volume is created on ONTAP 9. This in turn is mounted on a Docker container that hosts GitLab, the source code management tool used in this demonstration. The workflow that you're seeing here in both the traditional and the optimized approaches would typically be done by the CI admin. You'll see here how the GitLab is mounted on the Docker container. A repository of the Jenkins open source software is now created in GitLab. Once the project is created, Jenkins open source code is then imported from the GitHub location into a NetApp local volume. You will see that the open source code is now downloaded and available on the local volume. In practice, a CI volume is created for every code repository. In this demonstration, we're using only one repository, Jenkins open source software. This is the hub for all the build activity administered by the CI admin. This CI volume is created virtually instantaneously. The CI instance is now created and mounted inside the Docker container. This instance is then populated with the shared tools, compilers, libraries, and RPMs that are unique to each project. Up until this point, you've seen two different development approaches. Using the traditional method, a workspace needs to be created for each developer individually. In addition to the time that this takes, it uses considerably more CPU and network resources, especially when it comes to supporting multiple developers. Using the optimized method, a single CI volume serves as a common code foundation or source that multiple developers will work from. The key advantages are that it's much easier, faster, and more efficient to scale out a development environment, especially where multiple users are involved. Over the next few seconds, you'll be seeing the steps that are happening in the foreground, but what we want you to pay attention to is the load on the CPU and network resources for both the traditional method on the left and the optimized method on the right. You'll see that using the traditional method, there's significantly higher workload placed on the CPU and the network resources as they're used individually to set up the development environments and load down considerably higher volumes of code. Using the optimized method on the right side, there is some initial load on the CPU and network resources, but once the initial CI volume is created, there's considerably less resources required from both the CPU and the network in order to accomplish the same job. I want to take a moment now to highlight the differences between the traditional and the optimized method. Using the traditional method, each time a developer comes online, a build needs to be created. Using the example we've highlighted here, 3 developers take approximately 55 minutes in order to do this. There are some gains as each developer comes online. They typically comes from caching, but these gains will typically diminish as more load is put on an individual CPU. By contrast, on the optimized method, only a single build once CI environment needs to be created. It's from this that a snapshot will be taken, and then developers will clone from that snapshot. Both of these processes happen virtually instantaneously. I also want to point out one other key difference. In addition to the amount of time that it takes to create these build each time environments using the traditional method for the developers, there's also an additional load on the CPU and network resources that needs to be addressed. As more and more developers are added, typically additional CPU and network resources are required in order to support scale out with a degree of productivity. This is a key drawback when you're using cloud resources that you're typically paying for on a time and materials basis. in order to support scale-out for users. Once the CI volume is in place, a checkpoint or snapshot is created. It is from this snapshot that developers will clone individual CI instances to work on. One of the key advantages of this approach is that the cloning process takes up virtually no space and happens almost instantaneously. Using Jenkins, the checkpoints or snapshots and workspaces created can be viewed at any time. Using the Jenkins plugin, developers are now free to create their own workspaces instantaneously. Each workspace is created on a Docker container, and all the files are updated with the right set of permissions for each user automatically. As was pointed out earlier, the key advantages of the optimized approach are ease of use, speed, and most importantly, the efficiency with which it uses CPU, network, and storage resources. From this point forward, we'll only be focusing on the differences in the optimized approach. In this part of the demonstration, you will see how changes are made to each user workspace. As multiple developers are making changes in parallel, each of these changes triggers what's called an incremental build. These builds happen quickly, with significantly lower demand on resources because the builds are only being done on the changes made by the developer, nothing else. Period. Note here that the impact on CPU and network resources is minimal. Once made, the changes are committed to the Jenkins open source code repository in GitLab. A new build is then triggered in the CI volume, followed by a snapshot. Developers are then notified that a change to the CI volume has been made. Again, this has very little impact on CPU and network resources. At the completion of a scheduled full build in the CI volume, the contents are zipped and copied into a build artifact volume. This zipped file includes the source code, precompiled objects, dependencies, and .war and jar files. We're now going to talk about deploying applications into production using Apprenda. Committed and tested changes can now be deployed on the Apprenda platform. At this point, the Jenkins war file is zipped into the Apprenda manifest from the build artifact location. The zip file that is created is then pushed into GitLab. This whole process is automated using the Jenkins plugin we've been demonstrating. Here, you'll see the final build file, now in Apprenda, ready for deployment. You will see here now that the changes that we've made have been fully deployed, namely the NetApp logo in the upper left-hand corner, and Jenkins configure system has been changed to NetApp configure system. Throughout this demonstration of the CloudBees Jenkins Apprenda plugin with NetApp, we've highlighted several benefits, the main ones being rapid scalability of development environments with greater efficiency, predictable performance in multiple developer environments with parallel workloads, and all this is happening in a single consistent runtime environment that's sharing common tools and resources. Throughout this demonstration, we've been focusing on two key themes, namely improving developer productivity and improving the utilization of resources that are used to support those developers. For NetApp's part, we've accomplished this through the creative application of two key ONTAP features, snapshots and flex clones. The combined benefits have been talked about several times throughout this demonstration, but we'd like to focus on three key measurable outcomes, namely improved productivity as measured by the reduced amount of time it takes developers to set up their workspaces, faster time to market as a result of faster build times, and finally, improved efficiency as measured from the reduced demands on not only the CPU, but also the network and storage resources that are required to support the development and continuous deployment process. For more information and to learn more about NetApp's DevOps solutions, go to netapp.io and visit the NetApp Pub.